Hi everyone, welcome back to Pine Hollow, Auto Diagnostics. What we have in the shop today is a showroom quality 2006 Toyota Tacoma 4-cylinder 4-wheel drive. This thing is spotless. When the guy brought it over, I'm like, did you have it repainted? 104,000 miles. Customer complaint is the 4-wheel drive doesn't work. Interesting. History of the truck. If you look underneath, it looks like it's from South Carolina or something. The frame is absolutely mint. But the owner said the frame was replaced 8 years ago at 60,000 miles. So I guess it's a Pennsylvania truck, but he said the 4-wheel drive hasn't worked in about 10 years. And now he wants to get it fixed. Snow is coming this weekend, so I want to get this thing rolling on 4-wheel drive so it doesn't get stuck in my driveway. The customer did do some preliminary diagnostics. He has the glove box out, and here's the 4-wheel drive control unit. Now this is a standalone module. It's not on a network or anything, so we're gonna have to do this the old school way with the voltmeter, test light, and let's do some research on what this system, how it's laid out and what happens. Let me show you the symptoms of what happens on the dash when you try to shift it into 4-wheel drive. So when you turn the key on, the 4-wheel drive and the 4-low indicators just flash all the time. That's what the customer said. They just flash all the time, and when you try to shift it into 4-high or 4-low, nothing changes. You don't hear any clicks or actuators under the truck. So customer complaint confirmed. So like I said, the customer came prepared. He gave me a little summary of what he's checked at this 4-wheel drive ECU. Apparently there are some kind of like sense switches for 2-high, 4-high, and 4-low. He said this one he's concerned about. That is the front differential actuator or connect, electronic axle connect. He brought one new part with him. He said he has not installed this yet because if we don't need it, he wants to return it. But this is the front axle disconnect. You see there's just like a shift fork on there. It's either locked or free. So we have that if we need it. And he said he has taken the transfer case actuator off. I think refloat solder joints. Made sure the actual rod, he manually tried it. That's not stuck. The 4-wheel drive can be engaged manually. But the actuator is not doing anything, and this front axle disconnect is also not doing anything. He said he had it off. Again, everything looked clean, not corroded. So put everything back together. 4-wheel drive still does not work. Let's do some research on all data and see what we want to check first. So here we are in all data, and in the transfer case menu, I found a TSB. Says drivetrain 4-wheel drive indicator flashing, 4-wheel drive inoperative, and this has to do with actuator assembly differential. So this is the front axle disconnect, R&R ADD actuator, and let's see here. Repair procedure. Confirm 4-wheel drive system is inoperative and 4-wheel drive light is flashing. Okay. Remove the ADD actuator assembly. Then perform ADD actuator movement and resistance inspection per the repair manual. Replace the ADD actuator. That's it. That's your TSB. So I guess these things are known to stick or break. But let's start with the OE wiring diagram. So this is our 4-wheel drive control ECU. This is our transfer case shift motor assembly, and you can see 3 sense wires and 2 motor wires. Depending on if you're in H2, H4, or L4, one of these wires will be grounded at a time. So this is 2-wheel drive. You know, that bar is grounded when you're all the way up here. When you're in 4H, the TL2 is grounded, and when you're in 4LO, TL3 is grounded. So that's easy to check right at the ECU. And then for this front axle disconnect, again, 2 wires going to our actuator motor and 3 sense lines. So this is the default state when the axle is free. So you can see this ADD light green and black wire. That would be high because this is a pull down circuit. See, when this wiper comes over here and touches this strip, then this wire would be grounded. So when the actuator is free, or the axle is free, this should be high because it's not being grounded. 2 other wires, this one again would be high. DL2 would stay high when the axle is free, and then DL1 would go from being grounded to going high when the axle is engaged. So I printed that off. Here's the redrawn overall diagram, if we have to reference that. Then, you know, the pinouts, I highlighted the ones that we're worried about: DL2, DL1, ADD, and then these TL1, 2, and 3. That's for the transfer case. So I'm guessing the owner already went through these steps, but we're going to start from scratch and verify. Right now the truck isn't too high. We can verify that the front drive shaft should be free to turn by hand if the axle is unlocked, and do these same checks that he did, TL1, 2, 3, and DL1 and 2. Those are the sense wires. Now this 2.4 low 4L 4-wheel drive, I don't want to go there yet, but we will if we have to. Alrighty, so what's the setup here? Real simple. I'm just using a cigarette lighter adapter from the Power Probe kit. So we have no good power and ground here. And if I put a test light between these two, the test light should light up. Don't want to confuse your leads. Let's see, test light is grounded, so if it finds a power, it should light up, and it's not lighting up. So what's going on here? Oh man, this test light has seen better days, huh? Anyways, we don't need a test light for now. So we also have a meter. So if the meter sees a power, it'll show 12 volts, okay? And first I want to check that the module has a good power. Yes, it does. And then, trust me, I did check this with a test light. The ground, 1 millivolt is good. You always want to low check your grounds. Let's do that with the other test light. So let's go from battery power to ground. See, that's a good ground. 24 millivolts. Now, let's go through those sense pins and see if any of them are out of range. So we want to check the 3 for the disconnect, the axle disconnect, and the 3 for the 4-wheel drive. So right now we're in 2-wheel drive, so only this TL1 should be grounded, and then the axle should be free, so only the DL1 here should be grounded. Let's check that. Alright, so let's start our checks with just a meter. Start with this corner pin. That's the ADD wire. So if the axle is free, that should stay high, and it is 11.2. Let's keep going down the line. 6 millivolts, that one is pulled down. Third wire in, it's high. Fourth wire in is also high. So you see pin 26 was ADD lock, so this was 12 volts as expected because the axle is free. Pin 25, this was 0 volts as expected, and this was 12, and this was 12. So check, 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 check. DL2 and DL1. So this should be low in lock, this should be low in free. And that's a pink and blue and a light green. That's the next row up. So the light green wire (11.6), okay, and then the pink and blue wire also 11.6. Okay, now that's a problem. So this one was 12 and this one was 12. So we expect the pink and blue to be 12 because we're not in four-wheel drive. But this one, as the customer pointed out on his little sheet, is supposed to be pulled down, and it's not. Okay, so we determined that DL1 pin, which should be grounded when the axle is free, is not grounded. It's at 12 volts. So potentially there is a problem inside the actuator. But for now, we just want to do an easy bypass check. So with the key on, we have our blinky four-wheel drive lights. I just want to ground that pin out through a test light and see if the car is happy. So ground that out. Ground that out. Look, no more flashy lights. Let's see what happens when we turn to H4. You heard the whatever engage and disengage. We'll unground this. So now the green, it's still flashing. We might have to, it's in neutral. I don't know if you want to roll it back and forth. Okay, now we're definitely in four-wheel drive. And let's try to put it into 4-low. Okay, not happy about, doesn't want to go into 4-low. Okay, so I can reliably make it go into 2-high and 4-high just by undoing that ground. Now it's happy, got the green. Put it back in 2-high. And the blinky lights go away. So, problem is with this light green wire going to that front axle actuator. So, let's do a continuity check, make sure the wire is good. You know, loaded with a test light. And then, I guess we're going to have to replace this actuator unless, you know, what does this thing involve? Could pop the screws out. Maybe the slider in there is bad. It'd be easy to probably replace the whole thing, but I don't know how expensive this is, but the customer said if we don't need it, don't use it. Alright, so here's my continuity check. We're going to do both wires, the pink and blue and the light green. The light green is the one we're really worried about. So I have adapters under the truck at that connector coming up here. The black lead is connected to the pink and blue. The yellow lead is connected to the light green. So now, from this power adapter, I have a 1 amp test light coming from battery positive And this lead, if it finds the ground, this light will light up with 1 amp. Now what I want to do is send power to, for example, let's try the known good, pink and blue. So we're going to send power to here. It's going to come into here and make it all the way to the 4-wheel drive control unit, which I have unplugged and probed with the meter lead. And the meter lead still has the baby test light connected across those leads. So if the continuity is good and this circuit can carry current, the little test light will light up. The big test light won't light up because the current limit will be the baby test light. So let's try that. Let's try to feed 1 amp to here. Boom. That circuit is good. The pink and blue wire is good all the way from the actuator to the ECU. Now what about the green, the light green wire? Let's put that on there, run the same check. Alright, so same experiment with the light green wire. The needle fits nicely in there. And if we send voltage to the yellow trace now, like so, test light's not lighting up. Even without the test light, you know, open circuit. It's floating around even if we're sending voltage there. Let's repeat that experiment with the pink, or is it pink and blue wire. So now we want to send voltage to the black lead. Alright, we got 12.4 volts and load check it. Test light's on. 11.4 because there's a slight voltage drop across these. So confirmed, we have a broken wire. This light green one. So from here to DL1, from the ECU to our axle disconnect. Now let's take a quick visual inspection of the entire area and see what the next easiest thing to check is. Alright, so doing a quick visual inspection under the truck. You can see this is actually a Pennsylvania truck. We got lots of rust and crust, but the frame looks mint because it was replaced, but it was replaced 8 years ago. That's interesting. So here's the pigtail, and that connects to this connector right up here. I don't know if you guys can see that. Get some light and the camera in there. Follow the wire. You see that? Maybe from back here. Here it is. And the bracket's actually rusted off, and this thing was just kind of rubbing on the metal. So let's unplug this and do a continuity check from this connector, eliminate this pigtail. Well, we're done. I was just putting this over here, and I'm like, this electrical tape does not look factory. Do I see a butt connector? Oh, what a surprise. Let's unwrap this mess, take a picture for the owner, and then fix it correctly, and the 4-wheel drive should come back to life. Amazing. Alright, took off the electrical tape, and let's assess the damage here. Here's the broken wire, and it looks like it was shortened, and then it does look like shrink wrap, but this is the crappy type of shrink wrap that doesn't seal. And since this wire is hot all the time when the truck is on, corrosion got in there and it turned into green pus. So we'll have to extend that. And then there's another damaged wire, this red one. Kind of has a nick in it. You see right there? And some of the copper is damaged, so just to play it safe while we're here, I want to cut that, strip it back, resolder that, and then this thing should be back in action. So we'll take a picture of this for the owner, tell him at some point there's some wiring damage and a repair, and the repair broke. So I ended up extracting the pin with the broken wire because it was broken pretty close to the weather pack seal. And it's green and crusty inside too. So, man, that salty moisture got past the seal. So we're just going to solder on a new wire there, longer wire. Then we're going to solder this to the rest of the harness. That will kill two birds with one stone. Let's get that done. Got the beastly TS100 soldering iron, and I have the weather pack seal clipped on here, so all we need to do is melt some solder, get this pin nice and hot, and let the solder join the copper wires and the pin. Now I did clean it from the green crusties, so that shouldn't be a problem. Maybe I should have put some flux on here, huh? Viewer sent me some Amtech genuine flux. This is what Northridge Fix uses for circuit board repairs. I'm going to give this a shot. So let's see here, plunger. Just need a little bit. There we go. Screw that back on. Now, let's see if the flux cleans off. Smells good. Seems to have helped. I need a fume extractor too, right? Whew. I'm going to check that joint, should be good to go. Alright, final shot of the repair. There's the extension soldered onto the original light green wire. I'm going to tape all this up. Nice electrical tape, and reconnect everything. Take this thing on a test drive. Alright, all done here. This is wrapped up at the low spot. I put a little hole in the electrical tape just in case any moisture gets in there. It'll drain out, won't fill the whole harness with salt water. And then this, I fixed, extracted the remains of the rusty, broken connector holder, and then just put a zip tie on there. That's nice and solid. It's not going to rub on the metal. This is plugged back in. Moment of truth. Let's see if the 4-wheel drive works as designed. Alright, so key is on. We're back on the light green wire. We're pulled down to 0. And let's put in 4 high. I guess it's waiting. Maybe the axle is, there we go. See, now this is high, and we're definitely in wheel drive. It's happy. Probably won't let you go into 4-low for now, but back to high. Sweet. That's low, back to 4. Amazing. It works. Let's take it on a test drive. Alright, here we go. 4 high. We'll start rolling. We're engaged. And now with the clutch in, 4 low. We're engaged. Make sure we're indeed in low range. Yep. This is second gear, barely crawling. We'll put it back in 4 high. what's I'm not happy with now. Okay, so you have to be fully stopped, clutch depressed, then it's going to be happy. Back to two-wheel drive. Sweet. Alright, we're going to take this puppy for a spin here. A little rattle in the door, but let's see. Now on the fly, can we switch 4 high? Yep, that works. So it is an on-the-fly system. I think up to 60 miles an hour. I still like the first gen with the real, I guess that a 4 high button and then a 4 low manual shift. Back to 2. So that's it, just one broken wire due to a bad previous repair. It's a Toyota, so it wasn't the car's fault. But maybe they nicked it when they were replacing the frame, which only lasted 10 years. Huh, Toyota, what do you think about that? So, that's it. Thanks a lot for watching. Hopefully the owner will enjoy his 4-wheel drive. Should get some snow soon. We'll see you in the next one. Bye-bye.